Hi everyone, and welcome to Mike Likes Robots. Today we're going to be continuing the JetBot video series by looking at deploying a web app that can send MQTT messages to the robot in order to control it. We're going to deploy the web app using AWS Amplify. That's a service that you can use to build, host, and deploy full stack web applications with AWS services and no cloud expertise needed. So first we'll look at how to build and deploy that web app, which I already have ready, and then we'll look at how to write code for the robot to connect it to IoT Core and to subscribe to those messages and react to them. So let's start by looking at Amplify. Here we are in the AWS Amplify console, and what we can see on the page here is a bit more of a description about what it is and what it's capable of. So it's both a backend and a front end. You can add a backend which is hosted in AWS and responds to things like having DynamoDB tables or API calls, and then it adds UI components that it will serve to the front end. So what you actually see on the web page, it will also connect those components to the backend, so it actually makes those API calls and so on. It's got a number of options about shipping it and being able to scale easily. Those aren't relevant to us, but if you're interested, feel free to check out the page and learn more. But that's what the basics are. Let's look at actually deploying a web app for ourselves. I've got a Visual Studio Code window open with the contents of the Amplify app that we're going to be deploying. I'll leave the link to the GitHub repo in the description. It's just a standard Git clone. That's all the source code that you need. There's another couple of dependencies that need to be installed. You need to have Node available, and you need to have the AWS CLI configured. So I'll just show that I've got npm, and I've got Node. And I installed those with the Node version manager, which I installed using Chocolatey on Windows. I also installed the AWS CLI using Chocolatey, so now there's one more dependency that we need to install using Node, which is the Amplify CLI. So we can install that by using npm install -g to mean globally, so not just for the folder we're in, but for all instances of Node, AWS Amplify CLI. And I'll leave the link to this instruction set as well in the description. We can wait for that to complete, and once that's complete, we should have access to Amplify command line tools. We'll be able to build and serve a local server for our app and be able to publish it into our AWS account, assuming that credentials are configured. So let's try Amplify build, and it's saying that there's no Amplify app detected in this folder. That's because we've got the source code to be able to run this web app, but we need to set up Amplify. We need to tell it that it's an app and what components we need inside it. So before we get to that, we want to install the dependencies needed for the app, and to do that we can just do npm I. That will install all of the Node dependencies that we need to get going. Now if you want to have a look at the dependencies, we can take a look at package.json, and it will show all the dependencies that we need to build this project. Now we're going to set up the Amplify app, so to do that we'll run amplify init. We can keep the default name, and there's one part of this configuration that we need to change, which is that the start command is actually dev rather than start. And we can see that as well by going into the package.json and looking at the scripts. We've got build, which matches this run script build, and we've got dev, which is different from this start. Let's blow that up a little bit bigger. So we don't want this default configuration, we're going to change it. It will be the dev environment, the editor is correct, it is JavaScript, it is React, source is the right path, and our distribution directory path is actually dist when we build it. So we're going to enter that. Build is correct, and then dev instead of start. We'll use the AWS profile, at least that's how I've got mine set up. And there's only one profile to use. And now that will start to deploy the initial files we need for the web app. So at this point, anyone that's got access to this Amplify app will be able to pull the files that I'm pushing up to it, and we can start to collaborate on that. We can even have multiple instances of this app. Mine is named dev, but we could have one per person, one per feature, and then start to develop this web app differently. Not needed in this case because it's quite a simple application. So we'll just wait for this deployment to complete. It's creating the roles and the buckets for storing artifacts. Great. So at this point, we have the files we need in the cloud and we can start to add Amplify functionality. There's one example here, which is Amplify Add API. There's no APIs in our app, but we can start by adding auth because we will need authorization. So we're going to add auth. Now we can go through with default configuration using a username and no need for advanced settings. So now that we've added auth as a category, it will automatically create the Cognito user pools and identity pools in the cloud that we need to store user data and authenticate user data. It handles all of the stuff like creating passwords, resetting passwords, and there's even React components that we can use out of the box for creating users and signing in. You'll see those in a moment because I'm using the default one with the default styles. So now that we've done that, let's push. And the difference between push and publish is that push will just put the back-end resources in the cloud, which is currently what we want because we can just serve the front-end web app locally and connect it to the cloud. Or we can publish, which puts everything in the cloud, including the front end. But we want to be able to change our front end and reload it. So we're just going to push and wait for that to complete. Now the deployment's completed, let's take a look at what it's created in the cloud. Our app has appeared in our Amplify console. And if we check into it, we can see the backend environment has been set up and there's no hosting environment and we won't be using that for this project. We can see that the category that added is authentication. So if we enter into that, we can see our user pool and our identity pool. And we're going to need both of these for the app. So I'm going to view incognito so that I can start to create myself a user. I'll open the default user pool and I'm going to create myself a user with Mike, no email address, no phone number, and I'm going to set a password. So I'll set that password and meet you back at the console. Now that we've finished that step, we have our first user. Name is Mike and the confirmation status is forced change password. So I need to sign in with this user, and the first time I do, it will force me to change the password. So we can start to see how easy it is to add authentication to a web app and follow the same security practices that the best websites use. Now, on top of our user, we want to have a look at our identity pool. We can open this up and take a look at what's inside it. Now, the difference between a user pool and an identity pool is that a user allows a user to authenticate, meaning use a password or email authentication, whereas an identity pool is just any visitor to the website can automatically be granted particular privileges. Identity pool is what we're going to use to authenticate our MQTT message passing, but our user pool is what we're going to use to sign into the website, which is why we've got both. It's just what's required of the library that we're going to be using. So what we need to do is grant the identity pool permission to publish MQTT topics. And to do that, we need to enter our user access tab and look at our authenticated role IAM policy. So when we click this, it goes into the IAM role, and we can see these permissions are what the role is currently allowed to do, meaning nothing because there are no permissions attached. So what we can do is attach a policy, and I'm going to add the IoT full access managed policy. And that is not the right permission for what we're trying to do. If we're being secure, we would heavily restrict that instead of using the full access. But instead of worrying about exactly what permissions to use, let's get it working and fix that afterwards. So with that, our identity has the right permission to be able to publish MQTT, and we have a user that's able to sign into our web app. So let's launch a local dev server for the web app and see if we can sign in. we can use the Amplify Serve command, which will build the local version of the web app and host a local dev server for us to use. Fortunately, dev didn't work. Okay, so I'm back after a bit of debugging, and how I configured the Amplify project earlier was actually wrong. What we need to do is Amplify configure project to get back to that same menu setting, and then we're going to reset the project information. Most of it is right, so we're just going to hit enter to get through all of these. Now the part that's wrong is that you can see the build command is npm run script build, but previously I just wrote dev to overwrite it. You need to have the full command, which is npm.command run script dev. Then if you do that, it will override the project settings, and then Amplify Serve will push all the latest changes to the cloud for the backend and then run the front-end app in a dev server. So now we have access to that. And here's our robot controller app. So we can sign in with the credentials that I set up before. Click sign in, and here I'm being forced to change the password. I'm just going to use the same password again and change password. Here we go. Our site says we're logged in as Mike. We've got a sign out button, and we've got our 4 arrow keys. So if we click these, they light up. Let's do the final setup step and then try it out and see if we're sending MQTT messages. Here we are in VS Code. I've opened up the app.tsx file, which is the root TypeScript file for the project. And there's this IoT provider, which contains details for a pub/sub region. US West 2 is correct for me, and a pub/sub endpoint. And this we need to get from the console. So what we can do is go to the console, open the IoT core page, scroll down to the settings, and then copy our endpoint details from here. We want to keep the WebSocket prefix and the /MQTT suffix. Once we've done that, we can save, and that will just update our app locally. And now let's go to the test client and see if we start to get any messages come through. We'll subscribe to everything. And there's no messages. And now we'll click the up arrow. And there's still no messages. Now the messages still aren't coming through, and that's because there's one more step to granting permission to the web app to be able to publish MQTT messages properly. Now to be able to do this, we need the web app running and signed in, which is why it's had to wait until now. But if we open the dev console, we can take this line printed out here, and that's the ID of the signed in user. Now we need to open IoT Core, and we're going to create a new policy. We can do that by going to the Security tab, Policies, and then creating a new policy. And I'm going to call it IoT Full Access. I'll allow all IoT access on all resources. And again, you should cut this policy down to fit your needs if you want to be able to securely keep this web app up. So I'm going to create this policy. And now this setup amplify pub/sub page has the instructions. We want to run this command. We'll quit out of the app and do AWS IoT attached policy. Policy name is IoT Full Access. And the target is what we copied from the dev console. Now we've run this command, we should be able to refresh our dev server and start to see the MQTT messages coming through. So let's serve again. And we can see that clicking on the arrow has sent 2 messages per click. The first one is to go up enabled true, and then it's up enabled false. So we're saying move in the up direction and stop moving in the up direction. Now we can see our messages coming through on the MQTT test client from the web app that we've just deployed using Amplify. So we've seen our local dev server hosting the web app that we're using to send MQTT messages. but we want to be able to access this from anywhere. So the next step is to add the hosting capability and then deploy it into the cloud fully. So we can do that with another amplify add command. I'm going to amplify add hosting. And again, we'll use the default options, manual deployment, and then once we amplify publish, our app will be fully hosted in the cloud at the URL that Amplify gives us. And our deployment has completed, and it's given us this URL that we can open. And if I open this, I'm presented with the same sign-in menu that I had before. So our app is hosted in the cloud. We don't need VS Code locally anymore to run this app. We can just reach the URL that I've got here. So far, we've seen that we can build and deploy a web app for Amplify very simply and create users for it that we can sign in as. We've seen that we can access the local dev server and the deployed website on AWS from the browser. What we haven't seen yet is how to access the site from our mobile and what it looks like. So let's take a look at that now. And here is Firefox open on my phone, and we're presented with the same login screen. And if we click sign in and skip, we get the same arrow keys that we got on the desktop. Now we can use these and it will send the same MQTT messages we saw in the browser. Let's see how to set up the robot. So the first step to getting our robot connected to IoT Core to receive those MQTT messages is to generate that certificate for it. Now I've gone through this process in depth in a previous video, which I'll link at the top and in the description, so we're going to breeze through it. First, I'll use this page as README as a guide, but I won't be switching back and forth to it. I'll just be pasting in content from this page. So if you see stuff just appearing on screen, that's where it's coming from. So we're SSH'd into the JetBot again. We're in the complete workspace that we set up from last video, except we're not in the dev container. We're just SSH directly in. That's because we want to be able to use the AWS CLI to be able to generate IoT certificates and policies and so on. First, let's check that our AWS CLI is working. And that's returned the response that we want, which means we can carry on with the next steps. We also want to make sure our region is exported as a variable. I'll paste in this block and then overwrite the entries that I want to be different. So I'm changing the cert folder location to be the current folder we have open and a folder named IoT certs and config. I'm going to change as well the thing name, and then I'll leave the templates as they are because I'll be pasting the contents in anyway. The next step is to generate the certificate and the thing. And it looks like that failed because I didn't put a slash on the end of that certs config. So let's repeat that with a slash on the end and manually correct it here. And because the results of those commands are ARNs, that doesn't change based on where it is on disk. So we should be good to carry on from here. Next, we're downloading the root certificate and then attaching our certificate to our thing. That all seems happy. Next, we get our account ID and our endpoint address, and then export a port as a default 8883. The IoT config file will be the same current directory, but we'll manually create the file on disk, copy in to JSON, and then we're going to update the region as US West 2. And that's got everything set up as far as the default repository goes. However, this isn't actually what we want our config to be. We're sending on a topic like robot JetBot1 command. That's our MQTT topic. So we want to allow the possibility to publish on any topic starting with robot/JetBot. We also want to be able to receive on the same, and we want our JetBot thing to be able to connect. So my mistake, that's actually the template for the policy file. So this is the template for the config file. So I'm going to create this first and then rerun all of those replacement commands. Now this has replaced everything that we need except that we're going to be running our code from within the Docker container. And that means that this folder is mounted into the root. So we can just straight up delete that part for our Docker container to find these paths correctly. So that's our config complete. Now our policy is exactly the same, except it's a policy, not a config. So we just need to continue with creating and attaching this policy to our certificate. One more thing is that I don't want the policy name to be ROS2 robot policy. I want it to be JetBot robot policy. So I'm going to change that and then rerun the previous two commands. That'll leave a second policy attached to our certificate, which means it will be allowed to publish and subscribe to ROS2 mock telemetry topic, which it shouldn't be able to, but I think that's fine. So we can now attach this policy, and now our certificate is fully set up. Now that we've got the certificate set up, we want to check out the source code. So we need to just git clone into the source repository. Again, I'll provide the link in the description, but we're just going to do a git clone web app control. Now that we've done that, we can reopen this workspace in the container to try running it. And we're back in VS Code inside the container. We've got this new folder, web app control. So now if we take a look inside here, it's another ROS2 package, and it contains a node for listening to MQTT topics, the specific one that we want in this case because it's hard-coded, and it will take that and send out commands to command vel. So it will listen to robot jetbot1 command, and whenever it gets that, it will figure out whether it's enabled and what direction it's in, and then publish a command on command vel. To be able to configure this, we need to change the launch file. We've got this fix me path, and we need to change this to JetBot complete workspace, and then the IoT certs and config is here, and the IoT config.json is here. So this should be everything we need now to be able to build and run this node. There's one more step to being able to run this, which is that there's a new Python dependency, AWS IoT SDK, which needs to be installed. So we can install that directly and by opening the Docker file and adding it as a new line here. Now that that's complete, let's do a colcon build. And that's two packages finished building successfully. Now we need to source our install setup.bash, and then we can launch our new launch file, which is in this web app control, and it's called phone control.yaml. And we can see the MQTT publisher is connected to the endpoint, and the JetBot controller has started. So now, if we pull up the UI on the phone and start pressing buttons, we have full control over the robot. Now, those of you a bit more familiar with ROS2 might be saying, well, I can do all that messaging using ROS2 directly. Why would I do it with MQTT? There's a couple of reasons for that. The first one is that we're letting IoT Core do all the heavy lifting for us. We don't need to spin up servers or configure network settings to be able to let those messages pass across the internet. We just have to set up IoT certificates with those secure policies, and all of that side is handled for us. The second reason is that we can start to use that MQTT data in the cloud. And there's more information on this in my IoT Core video, which I'll put at the top and link in the description. So I encourage you to check that out for a few more reasons why. So here we have the setup running. We have the robot running our web app control software, and our phone is signed in to the web app. Now we can press the forward, the back, and the spin left, and spin right. So everything is working. Let's take it for a drive. So we've started remote controlling the robot with a cloud-hosted web app. We showed how to use AWS Amplify to deploy a web app into AWS that we can access from our desktop or from our phone. And it has arrow keys so that we can control the robot with it. We also showed how to write some code for the robot to listen to those MQTT topics and then react to them. In the future, we can extend this web app to start allowing us to select what robot it talks to, or to display a window with the camera feed from the robot. Thank you for watching. Let me know what you think in the comments, and I'll see you in the next one.